Welcome everyone to part 3, day 3 of my Machine Control Studio software training course. Today, what we're going to do is we are going to focus on the Sequential Function Chart development language. Why? Well, let me back up just a second. As I said on the first day, initially, this was a part of a 3-part series in which the first part of the training was the advanced motion controller, and I'd set that up to be a rotary print table, to emulate a rotary print table. So this course was the follow-on to that, in which I'm using Machine Control Studio to manipulate the advanced motion controller in the host drive. So that's where we're at, and I'm going to be showing you the sequential function chart development language today. Does that mean that's all you can do? No, not at all. If you want to do it in ladder, sure, you can do that. If you want to use a function block diagram, sure. Structured text, go for it. But this is just an example. So I'll review a motion control program that was developed. It's a kind of a solution project. And not only does the code manipulate the AMC, the motion controller, but there is also a POU there that is used to interface to the third part of this course, which was the MCH HMI. So one thing that I find to be very important when you're using our MCI control modules, whether it's the 200 or the 210, a good HMI is very important. By that, I mean you should expose as much diagnostic information to your end users as possible. So this was a 3-part course, and the last part was the MCH HMI, which I've already done and recorded, and it's on our YouTube channel. So I'm going to show you how to create an archive of your project too. Our tech support guys, not a lot, but on occasion, they'll get a call from somebody or an email from somebody that says, gee, I'm trying to look at this source code and I've got a project file and I've got 7,000 errors. What's that all about? So I'll show you how to avoid that when you're opening older projects, and also when you're trying to share your project with someone else. So those are the things that I'd like to discuss today. Once again, we'll be taking a break around 11 o'clock. So sequential function charts. And as I've mentioned, of all the development language, this is the one that's probably least understood, least used, and probably should be used. I don't know, most applications might be a little strong there, but there are applications that could take advantage of this, and I'm going to show you that. The benefits of sequential function chart, the biggest one in my opinion, is deterministic operation. I kind of showed you a little glimpse of a sequential function chart yesterday. And unlike ladder diagram, which just literally runs left to right, top to bottom, same with function block diagrams, by the way. Those two run left to right, top to bottom. This sequential function chart is deterministic in the sense that you always know where you're at in the code. It kind of cuts down on the debug and troubleshooting. It's perfect for machines that operate using a state machine. And, press the start button, do something else, and then end and restart again. That kind of operation or your machine lends itself very well to using a sequential function chart. And it's easy to troubleshoot because it's visual. And I was just talking to Jack there about a visualization. Well, in my opinion, the sequential function chart would make for a fine main screen on a HMI. It's here you are, here's what's going on. Oh, I'm stuck on this step. Well, let's go look at it. So it does have drawbacks though, in the sense that I don't pretend to know what's going on in the entire US, but based on my experiences in the places that I've been, it's not very well understood here in the US, and I don't think it's used very often either. And the other drawback is it can be difficult to control. And not that it can't be, but it can be in the sense that the stop and restart are kind of tricky. I'll show you how to do that here today as well. So those are the things we're going to look at. So here we go. In Machine Control Studio, when you have a POU that you have configured to use Sequential Function Chart as the development language, you're going to build your chart by using steps and transitions. So the toolbox contains steps that you see there, and transitions also. It also is going to utilize what are called actions. An action can be considered to be a subroutine. So your sequential function chart consists of steps and transitions, and the steps themselves contain actions. And the actions are where the functionality of that step occur. And the sequential function chart can be linear or branching. And there are two different types of branching. There's an alternate branch, and then there's a parallel branch. So I'll show you those. Here's an example of a linear sequential function chart in the sense there's no alternatives, no parallel branches. It is just an inline sequential function chart. So the light blue boxes there, those are steps. All right, and here we go again. If you have good eyes, notice that there's a double border around the init or initial step. That indicates the initial step, the double border does. And your sequential function chart can have only one initial step. Now, stepping through there, you see true. That's a transition. And again, like we touched on a little bit yesterday, these transitions are Boolean in the sense that they must always evaluate to true or false. Now, your transition can also include an expression, so long as the expression evaluates to true or false. What I mean by that, for example, I could say tank low and pump ready. So it's a Boolean logic, and so long as both of those conditions are true, my tank low transition there will be true, and I can move into the fill tank. Now within the step, and we're going to learn this, there's different types of actions. If you look in the right corner here of all these steps, actually, there's a little blue, triangle, whatever you want to call it. That indicates that the step has step actions associated with it. So here is an example of a step action. Now, I'll show you how to add an action to a step. And once you decide that you're going to add an action to a step, the code in the step can be coded using any language you would like. Including Sequential Function Chart, which doesn't make a whole lot of sense, and I wouldn't advise that. But here I have a step action that I coded using structured text, and it's just like any other. But at the end here, I have an expression that says if the tank level is not equal to 30.0, then tank low is true. So that is the code that gets me through this transition. And that's what I'm saying. When it comes to troubleshooting, what you're going to see is this step will be highlighted in blue, and it'll just be stalled there. So if I were to open the code up, which you can see when it's running and online, I'd come through and find out, oh, well, the tank level's current value is 70. So, or you understand what I'm saying. You can see very clearly what's holding us up on that step. So that's an example of what's called a step action, an embedded step action. There are also IEC actions, and I'll give you an example of those. That's the International Electrotechnical Commission. That's a European governing body, and they have their own actions. So I'll show you those. I don't use these very often. They're a little funky, if you ask me, but anyway, I'm going to show them to you. And then there's what's called a step entry action and a step exit action that you may also add. And again, the actions can be programmed using any of the development languages that you would like. Now, we've only focused on ladder and, structured text, and now I'm going to show you sequential function chart. The other two languages are function block diagram and then sort of a derivative of that, which is a continuous function chart. Both of those are graphical in nature, but we're only going to be looking at these three. So as I step through the steps, and once tank full is true, I'll go to the pump off step, which also has an action. And then when fill done is true, now we have a jump. So you see that little indicator there? That's a jump back to here in this case. So sequential function charts utilize jumps, and ordinarily I would not recommend that as part of any other program, but with a sequential function chart, given its nature, the way it works, you kind of have to. So that's an example of using the sequential function chart. So you can add an action by double-clicking on a step, which is called a step embedded action, right-clicking on a step. Right-clicking is how you add one of the IEC actions or an entry and exit action, or you can also use the icons on the toolbar. So the action for a step is active whenever the step that the action is associated with is active. Actions are executed at least one time. And I say at least because these IEC actions that I have referred to a minute ago execute two times. Once when the step itself is active, and then again after the step transition is true. So that's why I said, I'm sure these have their place, and I don't have a lot of, experience using them. So I find that to be a little strange. But anyway, that's how they are. So I'm going to flip over to Machine Control Studio here. Right? So I have an application started here for the MCI 210. I have a freewheeling program there, right? Now what I'm going to do is I'm going to show you kind of a common way, I'm going to show you one way of organizing your Machine Control Studio project. The freewheeling program is associated with the freewheeling task, so it is free running. Now, one thing I really don't like that. I don't like the fact that my POU is named the same as the task. I don't care for that. So what I'm going to do is I'm going to rename this. I'm going to right-click on it and then look at its properties. And the first thing I see is the name. I'm going to change that to main. Right? Now, automatic refactoring. You did rename the object to main. Do you want to automatically adapt all references? This is a really nice feature. Because what I just did was if I were to look at the freewheeling task, it has associated itself with the freewheeling of a POU named freewheeling. What this is saying is, well, wait a minute, you just renamed this task. Do you want to update the other references? Why, yes, I do. Right? So here's a reference to it here, and here's a reference to it here. Right? So now what this is showing me is that it has automatically updated the freewheeling task to operate my main POU. So refactoring is a very nice feature. There we go. And I can double check that looking right here. There it is. Where that used to say freewheeling, it now says main. All right, so let's get back here again. So in my main POU here, I'm going to leave it as is for now. But what I'm going to do is I'm going to add a task right now. So I'm going to right click here, add object, task, and I'm going to add a position task. All right. And I will create a POU for the task, and I will call it position. Well, fine. That's fine. The POU can be called position, but I'm going to choose Sequential Function Chart for the development language, right, like that. There we go. So there's my position task, and there's an interval for it. 1 millisecond is the minimum update that I could have. So I'm going to go here now. Now what I do traditionally here, and while we're at it, I'll just add another POU. So I'm going to go right here, application, add object, and I'm going to add a POU. Then I'm going to call this PLC program. That is a program, and I'm going to use ladder for that one. And I should also point out, one of the common questions that I get is, well, can't I change the development language once I have declared a POU? The answer to that is no. Once you have declared a POU like these, you can't go in and change the development language. You would need to delete the POU and then recreate it using the language that you would like to use. So now I have 3 POUs, right? So what I'm going to do is I'm going to edit my main, right? And I'm going to show you the syntax for calling these other two, or this POU. My position POU is on the position task, right? So I can't call it from a freewheeling task because it's being controlled by the position task. But what I can do is use this program to call my PLC program. So to do that here, there's a couple different ways of doing this, but the easiest way to call a subroutine POU, as it were, the syntax you would use is PLC underscore program, the name of the POU, left parentheses, right parentheses, semicolon. There. So what I'm doing here is I'm setting this up, setting Machine Control Studio up to be more like a traditional PLC, in the sense that you're using your main routine to call these subroutine POUs, as it were. And that's something that I generally do when I'm working with a traditional PLC. So just to show you that you can do the same type of thing here. Now let's go look at our sequential function chart, which is right here. So when you declare a POU and you choose sequential function chart, you're automatically given this initial step and a transition. So now I'll show you how to add these actions that I've been referring to. Well, actually what I'll do is I'm going to add another step. Well, no. What I'll do is I'll add a step action, an embedded step action. And the way you do that is just double click right there. All right, whoop. No, that's not true. Oh yes, it is true. There it is. It's a new dialog box they popped up. I haven't seen that. I've got the latest version here, so mine's a little different than yours probably. But here it is. We're going to add an action. And you can rename it. I'm just going to leave it as is. This is a step embedded action, so it's init active. And I'm going to use structured text like that. Okay, so when I add this, now watch what happens. Here is where I'm going to develop the code for this action in structured text. This is the structured text editor here. Notice that there is no variable declaration here. And that's because the variables in a sequential function chart are the property of the parent program, which is this, not the action itself. So let me put something silly in here. I'll say output 1 colon equals off semicolon. So I'm going to add that now, and the auto declare is going to come up again. What is that? Well, it's going to be a Boolean variable, and this is going to be output 1. So I'll click OK. Now, two problems. First one, I can't have spaces in my, see the red squiggle? So I need to correct that. Okay, so now I've got two variables there. That's Boolean. And notice also, it thinks off is a variable. As I mentioned yesterday, I should follow my own advice. These need to be true or false. See that? That's acceptable. On or off is not acceptable. So variables cannot contain spaces. And if it's a Boolean variable, it needs to be true or it needs to be false. Not 0 or 1, not on or off. So now I'll go back to the main, my parent POU, and see there's where the variables for these actions get included, right? So this one I'm going to get rid of. I don't need that. There we go. So that is a step action. Now I'll add a step. So I'll come here, and then I'll come up to the toolbar. Insert step transition after. Okay, there's a step. And I'll add one more. And there's another one. All right, so here I will add an entry action. And I'll do that by right-clicking on it. Add entry action. Okay, that's going to be my default. Maybe I'll stop that from coming up every time. So here is my step entry action. And I'll use sequential function or structured text for that as well. So I could add code here for this step, just like I did for that active action. So the entry action is going to execute after the transition is true and before any embedded action takes place. Right now, I don't have an embedded action in here like I do here, as indicated by the blue triangle. But if I did, the entry action would be the first thing it does. Then it would execute the embedded action if I were to have any. And I'll also give you an example of an exit action. So that's entry. Now I'll add an exit action. Fine. So you see how you get program editors for your actions. So there's an indication of an entry. There's an indication of an exit. And here is an indication of an embedded action. Now, what I haven't shown you yet is over here, we have properties, right? So here, if I go here, one thing that I like to do is I like to add comments. It should be a little more descriptive than that. But there's my comment. Now, what I would need to do to see that comment, you notice it doesn't show up anywhere. What I'd need to do is go up to my Tools, Options, then look at SFC right there. Here you can set the width of the step, the height of the step, the action, the qualifier. So it's everything to do with the step itself. But if I come to View, I will tick the value with name right there for the step. Right, so to see that truly, I would need to widen my step field a little bit. But the issue with that is, yes, I can do this and I can zoom, but these sequential function charts can be pretty involved. So use care when you're making giant steps and wide comments, right? I can still hover over it and it will tell me what the actual comment is, like that. But again, these sequential function charts can be pretty involved. So again, actions are executed at least one time. And I'm not going to go through and add any of these IEC actions. I have an example of that coming up. I'll show you what those look like. Right, so the entry action that we just looked at is executed once the transition preceding the step is true and before the embedded action or IEC action is executed. So the entry actions are indicated with a little E in like a postage stamp looking thing in the left corner of the step. Then your embedded actions are indicated with the little blue darkened triangle in the upper right corner of a step, right? You've seen that. And here are IEC actions, and that's what they look like. If I were to add an IEC actions are different in the sense they contain qualifiers that indicate how the step action is to be executed. So if you see here that P means that action, it's a pulse action. CodeSys executes this action one time as soon as the step is active, right? Now, unless there's an entry action. Okay, so there's all different kinds. Some of these are fairly useful. This delayed and stored. CodeSys begins executing the action, whatever the action is. Checklight 2 is another action, only after the given delay time has elapsed. Okay, so some of these are pretty useful, but again, in my experience, I've not used these IEC actions very much, so I can't really comment much on those. But this information comes right out of the help file also. And then exit actions, right? Exit actions are executed after the step action has been completed and the transition is true, deactivating the step. So let's think about that. This code that's in the exit action is going to exit after the transition to go to the next step is true, and before the entry action for, if there is one, on the next step would occur. So the timing of when these actions occur is also important. So exit action might be, all right, turn off any variables that were used in this step, or maybe a more practical example would be to update the state machine, so you know where you're at in the flow of the program. So the exit action's here, the entry action's here, the embedded step action is there, and if there were an IEC action, it would be flagged off to the right. Branching. To create a more complex program using Sequential Function Chart, you can add branches. Well, there's two kinds of branches. There's a parallel alternative branch, and there's a parallel simultaneous branch. So if you have a nonlinear sequential function chart that contains branches, the program logic is processed from top to bottom, left to right. The transition rules still apply. A step transition must evaluate to true in order to move to the next step. So here is an example of a parallel alternative branch. A single line designates a parallel alternative branch. So what this means is I have a step called wait. Now, the step doesn't contain any actions because I would see that here. But in this example program here, it's going to start with init. It's going to wait until a cycle start push button. It's going to flow through here. There's no actions here. And it's going to start looking at, is the stop push button true? If it is, it's going to go back here and wait for the cycle start. Is light 1 true? If it is, it's going to do this action or perform the action associated with that step. If light 1 is on, that's the transition, which I would have set up here in the code for this step. Then it's going to jump to wait and do it again. So it's just going to hang out here. Now, same thing here. That's why it's alternative. It's got 3 alternatives here. It's going to stop, it's going to turn on light 1, or it's going to turn on light 2. So the question might come up, well, what if all of these are on? That would be a problem, and it would do all the actions. I mean, in my example, it'd become a foot race. If stop came on before those guys, well, it's just going to come back up here again and wait for that. But if stop's not on and both of these are on, it's going to execute whichever one comes on first. And it will also do that one. So you do have to use caution when you're using these alternatives. A practical example of these alternative branches would be, I don't know, I'm the owner of Pete's Pretty Good Widget Company, and we're making widgets, and I have 6 widgets that I make. So I might have a transition here that says, widget 1, widget 2, and the manufacturing process for each widget is slightly different. So I can use that as a means of selecting which, you can use it kind of like a recipe almost. So, and that's where I see the power in these things. You have different functions that occur and are called out by whatever transition is true. So that's a parallel alternative example. Does anybody have any questions? Everybody's being pretty quiet out there. All right. Okay, well, then we'll look at a simultaneous parallel example. So here, same type of program here. I've got an initial step with code in it. I've got a transition called activate lights. And here I have a double line. So this is a simultaneous parallel branch. So in this example, as soon as activate lights is going to come true, the step actions in all three of these steps are going to execute simultaneously and in parallel. And then at the end here, I have an example of what's called a convergent transition, in the sense that there are no step transitions after each of these steps. There's only this one, and this is an example of using an expression as a transition. If light 1 is on and light 2 is on and light 3 is on, then I'll come back up here again and wait until activate lights transition becomes true. So you have parallel, simultaneous parallel, and parallel alternatives branching that look like that. Now, we've talked about this a little bit already too, but unlike the other POUs we've developed, variables that are declared during the programming of a step action is not local to the action. They're local to the parent object, which is the Sequential Function Chart POU itself, right? So just like we did, I don't see any variables here, but I see them here instead. Oh, not here. No, wrong. I see them there instead. Excuse me. So that's important as well. Before we move along, one other thing that I use as part of the solution program that I'm going to be showing you here after the break is global variable lists. Again, what we've done to this point is used all local variables as indicated by their scope falling between the words var and end var. Well, what if I want a global variable? So local variables here are only accessible to this POU right here. So what if I want a global variable that can be accessible by any of these POUs? Well, to do that, we will come to the application, right-click, add object, global variable list, right there. Now, I like to give these a name. You can have multiple global variable lists also. So I like to, GVL1, something really clever like that. So when I click open, well, here we go. All you see here is the variable declaration pane that would be part of, it's this, except now there's no code here. It's all variables. So I'll come in here and just create one. So for example, I'll create one that says, step 1. You can use underscores, running. And I'll put a colon. Now it's data type, which is Boolean. And I'm not going to I'm not going to set that to a immediate value, or I'm not going to initialize that. So I'm just going to put a semicolon there to end line. Notice the red squiggle went away, so that's valid. So now I have a global variable. And to show you how that works, I'll come into the main POU, which is this one, and I will access the variable, the global variable I just created. So I'm just going to put if, then I'll use F2 to open the input assistant. So your global variables that you declare will be part of this application tree. See that? GVL1. So I will bring that down. There it is. If, and notice what it does. You need to include or preface the variable using the name of the global variable list in which the variable is defined. So if I'd have gone in and just said, yeah, it's a global variable, and I'd have got rid of GVL1, if step running, then see what it does. It says, oh, well, you want to create a local variable. Well, no, I don't. So I'm just going to show you now that I've declared that, right? This time I'll use smart coding, and I'll just type the name of my global variable list, GVL1, 1 dot. And see, there it is. The period is a deconstructor for the global variable list object. So it shows me all of the elements of that object, and I only have one. So there it is. So you'll find yourself using global variable lists pretty frequently, I would say. Especially if you're using digital and analog I/O and sort of host drive related functions that, you know, might be part of any POU within your CodeSys project here. So again, you can have multiple global variable lists, but they must be, you know, given sort of a unique name. And then when you want to utilize any of the variables found in that list, you must preface your statement using the name of the list that the variable was declared in. So you're going to find yourself using these pretty frequently. Okay. Do we have any questions at this point? Well, good. All right. Okay. Well, let's take our 10-minute break here, and I will start up again at 11. All right. Again, where we left off, we were talking about variables and the global variable list. And again, just to reinforce, with the sequential function chart, the variables that are declared as step actions become local variables as part of the parent POU. So that's a little different. Now what I'll do at this point is I'm going to open up and show you the program that I developed to operate the rotary print station that was part of the AMC course that started these things. So I'll open that up, and I'm going to post this recording to our YouTube channel once we're finished here today, and this will be available next week sometime. So if you're not a subscriber to our YouTube channel, I invite you to do that. Given the fact that most everything that I do these days is going to be virtual now, so it's all going to be either on our learning management system or YouTube. If you would like an archive of the project that I'm going to demonstrate, just send me an email to my email address there, training.charlietangoalpha@mail.nidec.com. So let's have a look at the print carousel example. Not that one. This one. Okay, so what is all this about? Well, let's start at the beginning and show you what I've got. This project has 3 tasks: a freewheeling, initial, and position. Now, we touched on initial a little bit, and I'll show you my initial POU. There isn't much in there, but again, the initial task runs once on PowerUp, so it's considered to be the highest priority program just because it's the first thing that runs. But unlike the other POU programs, this one ends. This one does not self-loop, as it were. So all I've done here is I've just included a line of code that disables error checking for the encoder, just as an example. Now here's the syntax that I use to save parameters in the drive. You know, if you've used Connect software before, you say, oh, okay, well, let's see here. Okay, I'm online. I'm just going to save parameters in the drive, right? Well, to do that programmatically from within Machine Control Studio, you write the value 1001 to any menu parameter number 0. So here in this case, I'm writing 1001 to menu 3 parameter 0. That could have just as easily been menu 10 parameter 0. So that's the syntax I use to save code, and that's the only thing that's in this example. But, you know, typically this initial task POU would be pretty long and pretty involved. You would have all of your, you know, your motor setup, your motor feedback setup. You might initialize variables, global variables again. There's another good example of global variables. I'll use them here in this POU. And you might reset the drive and all things needed to commission a drive. And the point again being with the initial POU, this is used so that if the host drive fails, these modules, these control modules, very rarely have problems. So you just unplug the host the control module from the drive that's having a problem, replace the module back onto the new drive, and on PowerUp, the initial POU will commission the drive in its entirety, and away you go. So that's the initial task in the initial POU. Then I've got my main POU, which you're looking at here. So this one is in my position task here. Then I have my PLC program. Now, let's look at the task configuration. So the freewheeling task is running the PLC program and my HMI interface, right? So the example I just showed you where I had a main POU and I called other POUs, it's probably better to actually put them right here in the task configuration like that. And, you know, the order, it's going to be from top to bottom as to what gets executed. So that's my freewheeling task. The initial just runs the initial, but position now, that runs my main sequential function chart. So that's how those things happen. Now, one thing I should point out, you know, if you develop your project, download it to the controller, and you look at your screen and you're online and you don't see anything updating, you know, none of the variable values are true, your PLC network is not blue, that's a pretty clear indication that that POU is not being serviced. So go back and check to make sure that it's either being called as an action or as a subroutine, or that it's associated with a task in the task configuration. That happens not all the time, but on occasion. All right. So now what I'm going to do, here is the POU for my motion control program. I'm just going to zip this up and get it out of the way. And I will pin you out too. So there we go. So how this all works now is my PLC program. Let's look there. Here's my PLC program. Okay. So as I mentioned, this Machine Control Studio project is designed to interface to an HMI, specifically our MCH HMI, which I covered in the third part of this virtual training series. So let's look. I have a push button here called GVL1. It's global HMI stop push button. So let's go look at that program. And here's how I have that set up. These are all global variables. Here's my drive enable, hardware enable. That's read only. That's what these codes are. RO, read only, read only, read only. So these are all the things that I'm going to expose to my HMI. Okay, and then down here, read, write, read, write, read, write. Now, my HMI would be talking Modbus TCP IP. Okay, so what you don't see as part of this program is that in the HMI program, you need to assign Modbus register addresses to all of these menus and parameters that you want to have access to. There is another video on my YouTube channel in which I tell you how to do that, how to assign Modbus register addresses to, drive parameters. So that's the interface there. So these things, this program is being serviced at an interval in the freewheeling task. So my HMI is being constantly updated with whatever's in this POU. So that's that. Let's go back to the main again. So I have that start sequence button, and that comes from here. This is how I stop it, but here's how I start it. This would come from the HMI. All right. But I've added a parallel network here that has a maintenance contact. So let me go online. I've got this loaded into my demo now. So online, log in. I should point this out too. With the MCI 210, once you have initially downloaded your project into the controller, subsequent times when you go online, it's going to present you with this dialog box. And the options are log in with online change. And what that means is it's literally just going to go online and show me what's in the controller, present in the controller, present in the MCI 210. Log in with download would download the code. I may have gone in and made changes and edited things. Well, if I wanted to download that, that's what I would do. Log in without any change would be, all right, I just want to log in, similar to this one. Update boot application. That's if I want to update the project that runs in the MCI 210 when I first power up, then I would tick that. I'm just going to log in with download here. I'm just going to download this project. Uh-oh. Errors. What's my error? Okay. I've got an internal error there. So what I'm going to do is I'm going to come up here and I'm going to build, clean all. This project is an older project that I had used, that I created a while back. So I'm going to clean all the log files and things like that. And now I'll try it again. Here we go. There it goes. Now this is an option. Remember yesterday when we looked at project properties on the POUs tab here? I have an option for downloading source code, and I chose prompt. So it says, do you want to download the source to the target? I've already done that, but I'll do it again. I'll say yes, just so you can see how that works. So it says, okay, well, we have to save it. Okay, just like at home. Yes, all right. There we go. So now down here, what it's doing is it's created an archive of this project, and I'll show you how to do that. And here is the download. This download here is indicating the progress of the source code download, not that one. So here we go, downloading stuff. This is very important. I touched on this on day one. This would be probably the last thing you would do after you've completely downloaded completely debugged the code and everything is working. The last thing you would do, if you wanted to, would be to download the source code. So here we go. Right now, as always, the program is stopped. So I'm going to start it by coming up here to this icon. There we are. So here are my things, right? There's the PLC program. So if I go to the main sequential function chart now, here we are. It's running, and I'm on this step. Now I can double click here and look at the code within that step, right? So that's the embedded step action for the init step. So basically the way this thing works, this project works, is I have two different products that I'm going to be printing. So let me shift over to a different view and show you my demo now. There's my demo. So there's two different products, product 1, product 2. And basically it starts by homing the motor. Now I've got, if you look at my AMC training on YouTube, I go through all the AMC setup, scaling, things like that. But it's set up so that it's a rotary print station, and product 1 is going to stop at positions 1, 3, and 5. Product 2 is going to go to stations 2, 4, and 6. So basically I've got 6 print stations that are 60 degrees apart in my fake project here. So I'm hanging out here on the init step right now, waiting for the start to be given. So I'll go to my PLC program now, and the first thing I'll do is select the product I want to run. So I'm going to scroll down here. I don't have them both on. I want to run product 1. So I've got a maintenance contact here. Double click. Right, there's the prepared value of true. So now I'm going to hit Control F7. Right? And I'll turn that off. It's latched now, so I don't need to leave this on. There we go. So I've selected product 1, and now let's start it. Start sequence. I'm going to turn my drive enable on. There we go. And now I'm going to start it. So the first thing it's doing here is it's homing the print table. And it's looking for a home sensor. So I will activate that. I'll try to get it around so it's up on top. There we go. I don't need to leave the start on. So let's watch it step through. And that's all it does. It just goes, gives 5 seconds at every station. Transition's true. It flies through here pretty quickly, but trust me when I say that had to be true. And I've got this product counter going on here too. So if I open up the code for that, just to show you that it is in fact running. Watch this now. There it is. That's my product counter. So that's one of the things that I bring out to the HMI also, is to show this product counter. So that's running. Now, if I want to stop this, I mean, if there's a problem here somewhere and I want to stop this, what I need to do, and I've got this in my PLC program here, the start is cleared, so it's not going to try to restart. But if I come up here now, if the drive is tripped or I have a stop push button, I have what's, as a coil, I have turn on quit error, but this reset, sequential function chart reset, that is the system property that I showed the other day that I enabled and declared, and that's how you stop and restart a sequential function chart. So let me try it. Oh, of course it didn't work that time. Of course it didn't. All right, well, let's see what's going on here. Oh. Oh no, that's right. Yeah. I've got the start. Oh, it started. It stopped and started again. Sorry about that. So here we go. It's homing again. There we go. So how that happened here is I'm going to go back to the PLC program here. All right, start sequences there. That's latched on. Okay. So 2 products. That's pretty simple. There's not a whole lot to it. Basically, that's it. Right? But the key takeaways here are, in my opinion, this would make for a fine main screen on an HMI. Because here's what the operator needs to know. Where are you? You know, I'm here. Oh, okay, I'm stuck here. So if I'm stuck there, well, let's go in here and have a look and see what the... And while we're here, I'll show you a little of the motion controller stuff too. And I'll start up here at the home step. So that stuff, that just takes care of sequential function chart stuff. Same here. But what I've done here is I have created my own in position window, as it were. So what I do is I created a variable here called current position. Menu 33 parameter 4 is, if I hover over it, it says that is the AMC motor position right there. So as I'm in this step, I load wherever the motor is. Then I go through and I say if the table has been homed. If it's not been homed, well, it already has been homed now, but if it hasn't, then here's how I execute my home routine. So what you'll find out is menu 40 in the drive is everything to do with homing. So I'm using home mode 8, which just says home to a sensor. All right, that's a whole separate conversation, but homing to a sensor, I set my speed in menu 40 in user units per UUs per millisecond are the terms being used. Acceleration, deceleration. Menu 34 parameter 7 is the key to the AMC, because this is where you put the AMC, or you shift the motion controller into home mode, into absolute position mode, into relative index mode, into gearing, into camming. So when it's time, after I've got all that, I say, okay, we'll just put it in home mode. Right now you see it's in mode 5 because it's indexing. Oh, I'm sorry. It's in mode 1. Home mode is mode 5. All right. And then I just say if the current position is, and there's my tolerances, if my current position is greater than negative 20 UUs, and the way I've got it scaled, that's 20 thousandths of a degree, and less than plus 20 thousandths of a degree, then I'm in position and I will declare the table homed and move on. And I do the same thing here in the positioning steps, right? So what I do here is I'll set the speed, accel, decel, and position, and then I'll move it to that position using that statement there. And if the current position is greater than or equal to it's supposed to go to 180 degrees here. So I said if the current position given the scaling is greater than 179.900 degrees and it's less than 180.100 degrees, so I'm saying my in position window is plus or minus 0.2 of a degree, then I'm in position. Then I start a timer, so whatever happens during the printing can occur here. And here's another example. Here's an example of calling a function block from in a structured text program, right? So start print 3 timer is true, right? So here are my preset time for my timer, right? There's the output of my timer right there. So just because it's structured text doesn't mean that I can't run function blocks, which are normally graphical. So that's pretty much it for my project, for this particular project. It's simple, but it works. Does anybody have any questions on that? Okay. All right. Then I will move along. Okay. All right. So that's that project. Now, let's say, okay, I'm done. Project works. Finished. I want to share this code with a coworker, customer, whatever. There's only one way to do this correctly, and I'm going to demonstrate that to you. What we're going to do is we're going to create a project archive, and the file extension will be .project archive. We get many questions from tech support by people who send just the .project file to an end user. Let me show you what that looks like. Oh gosh, let's go here. I don't know. What can we do here? We'll go here. All right. All right. So let's go here. As I mentioned, your projects are stored in your documents folder. So documents, control techniques, machine control studio. That's the default location. So here's all my projects. Now notice that your project, your Machine Control Studio project, contains multiple files. What some people do when they want to share code is they will just send this project file with the extension .project. Now, the reason that's a problem, let me flip back over here. The reason that's a problem is that project file contains code. Okay, yes, it does contain the code, but what it doesn't contain are the libraries that are used to develop that code. And this is probably a good time to talk about upgrading Machine Control Studio. I need to because I'm kind of the beta test guy. So I need to update Machine Control Studio just to make sure everything works and help out the engineering team in the UK. But my advice to you is, unless you have a pressing need to, I would not upgrade Machine Control Studio. Most of the time when we do upgrades, we being the engineering staff in the UK, they'll do an upgrade when there's a feature that's been added, or when SSS, the people that make CodeSys, have implemented something that affects vendor versions like ours. So yeah, if you want to see new features, and there have been some really nice ones that have been added that you won't have access to if you're not using the version of Machine Control Studio that supports it. But if you're a machine builder, I know you guys from Fori there, for example, if you're a machine builder and you have something that works, my advice is just to go with it. You know, it's the old don't fix it if it's not broken thing. Because what happens is I get a project file from a customer. I try to open it. It'll open up with all manner of errors saying that the libraries are out of date and the references are wrong. There's ways to fix it, but it can be a little cumbersome. So when you create an archive, it contains all the code and all the libraries that are referenced during the creation of the code. So let's see how to do that. So I'll come back here. We'll use this project, right? So I want to create a project archive. So I'll come up here and I'll say File, Project Archive. Now, if I'm on the other end, if I'm the guy that received the archive, I would select Extract Archive, point it to wherever the archive is, and extract it and use it. But I'm going to create one, Save Send. So here it's asking, well, what archive, what do you want in the archive? Reference devices, reference libraries. You really don't need that, but I just leave it there. So this is what I would do, just leave it at its default. You can include additional files with this archive if you want. But I'm just going to click Save. Now if I click Send, what that would do is that would create the archive and then open up my email editor and put the archive as an attachment. Well, that's kind of handy, but in my case, being a remote worker, that's not going to work so good. So I'll click Save. So it's going to come up and say, okay, well, where do you want to store the archive? Notice there's the extension, .project archive. And I'll just leave it right where it is. Save. So now, if I want to send that to someone else, let's see, hopefully there it is. If I want to send that to someone else, here it is. There's the project. It's in here somewhere. Let me update this. Go back here. There it is. Right? So there is what I would send to somebody who wants to view my code. Same kind of thing if you're using the onboard target, because you can't store source code on the onboard target. So you would need to send this archive to someone who wants to go online with the online onboard target as well. So that's a very important skill to know when you're using Machine Control Studio. So I just did that. Another common issue is when you open older projects, right? So I've got a brand new version of Machine Control Studio. So if I go try to open a project now that's created with an earlier version, what's going to happen is it's going to open up and tell me, it's going to say, well, would you like to update? Well, let me just go do it. I'll show you. So I'll say File, Open Project, and I'll just choose an old one somewhere. Let's go here. Let's go to Control Techniques. Machine Control Studio, and I'll choose an old one. Let's see. Let's sort this way. Ooh, boy, here's one from 2017. This is bound to be a problem. So I'll just open that. And here's what you get first. First thing you see is the compiler version. So the compiler version that this was created was version 3.5.9. So the newest version is 3.5.16. Now, if I say set all to newest, that means that I won't be able to open this project any longer using the version of Machine Control Studio in which it was created. Because I'm updating now. It's upwards compatible, but not, or it's backwards compatible, but not upwards. Okay. So if you see this, what you can do is just say cancel, and it won't update anything. Now, I don't know. Oh gosh, that was not a very good example. There's nothing there. Let me try a different one. Oh gosh, let's see. Well, let's go here. That's 4 years old. Same thing. Comes up and gives me that. I'm just going to say cancel. But here's what you'll see. If I were to go to build this, build, whoa, 5 errors. So the first thing you'd want to do is you want to update the device. And you see that question mark? That's a clue. It says, well, I don't even know what this device is. So it's a device called Fred, which is unusual, but it's a Unidrive M200. So how do I get over that? You there again, you right click, update device. right? So somewhere in here, I'm going to find a Unidrive M200. There it is. So now I'll just update that device. Okay, and the question mark is gone. I'll rebuild it again. Uh-oh. 111 errors. My goodness. So I have a little work to do here. Well, probably could have chosen a better application, but what I would need to do is go to Library Manager, and this particular project was developed for our partner company, our sister company, KB Electronics, one of their drives. So I would need to go to the Library Manager and load their library here, and then go through and build again, because that's what it's complaining about here. So updating the device generally takes care of it, but in this particular example, there's missing libraries here that I would need to add. And again, what did I do? I just opened up the project file. If I had opened up the project archive, I wouldn't have seen any of that. So not to beat a dead horse to death, but that's a relatively common issue. That's all I have for you. Does anybody have any questions, any comments? Thank you very much for attending today.
Going back to when you said you can programmatically save parameters to the drive by writing 1001 to the 0 parameter of any menu, does that save all parameters or just the parameters from that menu?
All parameters. It's just the same as if you would have used the keypad and said save parameters in drive, or you would have clicked save parameters in drive and connect.
Okay.
So it gets all of them, and it also gets saves all of the setup parameters for any expansion modules you might have in any of the slots on the drive.
Okay.
Right? So the reason I use 1001, you may have heard in the past, if you've used our Unidrive products, to just write 1000 to any parameter 0. Well, that works unless the drive is tripped. So 1001 will save drive parameters under any condition, tripped, under voltage, what have you. So that's why I use that. Good question.
Okay.
Any other questions? Wilbert, you all right?
Hey, I didn't have a question, more so a comment. I think for myself, I could see the benefit of using the sequential function charts.
Yes.
Just because we deal with a lot of end users or customers, and sometimes just even people that are higher up in the company that might not be, that familiar with Machine Control Studio, that just want to see a high level, how does this work explanation.
Mm-hmm.
And I think that's something that I'll probably start implementing a lot, just because you can have the different languages within each.
Yes.
Look at my notes here. Sorry.
Yeah. The step actions can be developed using whatever language you're most comfortable with.
And that's something I think I'm going to benefit a lot from, because even my boss says the reason he sent me to do this is because he isn't too involved with the PLC programming side of things, but this would make it a lot simpler to explain to him how our PLCs are working for specific customers.
Yeah, good for you. I hope that works out good for you. I think you're right on there. That's why I like them too. Good.
I got a question about the different versions. Like, let's say in my case, I program a machine this year, and 10 years from now, someone wants to go in and just do the code to troubleshoot and not necessarily make changes.
Mm-hmm.
Would they have to have a project, or are older versions of Machine Control Studio available to download?
Yes.
Okay.
Well, you could go either way. I mean, you could tell your customer, okay, and that's kind of what I think a lot of people do. OEM kind of people like yourself. It's okay. I have a customer and we have standardized on Machine Control Studio version blah blah blah. So Mr. Customer, if you want to have the ability to go online and look at things and whatnot, I'll send you the version that we use. That kind of avoids all those issues.
Okay.
Yeah, and so that's pretty common. I don't know what the guys at Fori do, or what their input might be, but it's very common for OEMs to just sort of standardize on a version and leave it at that.
That is what we do. We have a version of Machine Control Studio that we know that our machines work with, and that's what I've been told to stick to.
Yep, that's sound advice. Sound advice. So that's what I would do too, Jack.
Okay. Yeah, it's for me coming into being green with everything in general. I run into that a lot with our older equipment because can't get the software for it anymore, or versions, or
yeah.
primarily that's the big one. So.
Yep, that's what I would do too.
Very good.
Okay.
I have one more question, or maybe two, I guess.
Okay.
When I was messing around with Machine Control Studio earlier today before the startup of this class, I had my variables instantiated up above, but then halfway through programming the function block, I was like, oh well, this tag should maybe be different, so I changed the name, and then it did not change it within the function block code. Is there any way to do that, or do we have to manually go through and change each use of that?
No,
manually?
Good question. What you can do, so you've developed your own function block?
Yeah, I was just messing around with
good.
A simple function block.
Beautiful. What you do is you right-click on your function block and say update.
Okay.
And that will update the internal code.
Right-click on function block.
If you're using a graphical, right? If you're using your function block in a ladder diagram or a function block diagram, you can right click on the graphic, and I think it says update.
Well, how about, so I'm looking at the function block code right now with the tags up top and the code on the bottom, and if I change the tag.
Oh, yeah, no. You can update it if it's been implemented as part of a POU somewhere. So when I'm developing, that's what refactoring is for. And depending on what version of Machine Control Studio you have, you may or may not have access to refactoring. I don't know. That was something they've added. But that's what refactoring is. And that kind of popped up when I was doing an example here too.
Okay.
Yeah.
All right.
All right. Is that it? Anybody else? Edgar?
I'm good.
You're all good?
Okay.
All right then. Well, thank you very much for attending today, this week. I appreciate it. We appreciate your using our stuff, and watch our webpage. I'll be doing some more of these type of things, and if you have any suggestions for what you would like to see put into this format, just go ahead and send me an email, and who knows, maybe I'll just do something. I'll do what you ask me to. So thanks a lot, and we'll see you later.